In this episode, we will explore tuples, a slightly less well-known data structure in Python. We will cover how to create them, their properties, and highlight the key differences compared to lists. Let's get started. A tuple is an ordered collection of elements similar to the list we have already discussed. Like list, tuples allows access to their elements using indices. However, what sets tuples apart is their immutability. Once created, they cannot be modified. Attempts to add, remove, or overwrite elements in a tuple will fail. Tuples are created using parentheses, similar to how we use square brackets for lists. The simplest example is an empty tuple. We confirm its type using the type function. When creating a tuple with only one element, there is one important detail to remember. You must include a trailing comma after the element, otherwise Python will interpret it as a simple value enclosed in parentheses, typically used to group operations. This requirement applies only to single-element tuples. For tuples with more elements, the trailing comma is unnecessary. Like lists, tuples can contain elements of different data types, including other tuples. You can access element in a tuple using square brackets with indices, just as you would with lists. You can use both positive and negative indices, as well as slicing with start and end indices. If needed, you can also specify a step to select element at regular intervals. Slicing always returns another tuple. This gives you many options for extracting elements. However, attempting to override values in an existing tuple will fail and result in a Python error. It's important to distinguish between the immutability of the tuple and the mutability of its elements. If a tuple contains immutable objects like a list, you can modify the list's content. However, you cannot remove the list from the tuple or replace it with another object. As a sequence, a tuple supports operations similar to those for lists. You can concatenate tuples using plus operator, replicate them with the asterisk operator, and check for the presence of an element using the in keyword. Just like other sequences, tuples can be compared using comparison operators such as less than or equal to, greater than or equal to or not equal to. This works somewhat similarly to numbers and comparisons you may know from math lessons. However, the comparison is performed element by element, starting with the first pair of elements. The comparison continues as long as the elements of comparable types and their values are equal. If a pair of elements satisfy the condition or the elements are exhausted, the result of comparison is determined. Python provides a built-in tuple function to create an empty tuple or convert other sequences like lists or strings into tuples. A useful feature of tuples is unpacking their elements into separate variables. This is not unique to tuples, but applies to sequence in general. Ensure that the number of variables matches the length of the sequence, or the operation will fail. If during unpacking we are not interested in all data, it's common practice to use variable name with a single underscore for irrelevant elements, while keeping the important data in appropriately named variables. This is not a unique feature of Python, but rather a widely adopted convention among programmers. In addition to unpacking, Python offers the opposite operation. A series of values separated by commas and assigned to the single variable can be stored as a tuple. Python provides many built-in functions that operate on sequences in general, not just on tuples. For instance, the len function, which we have already encountered with lists, returns the length of a sequence. Discussing tuples is a great opportunity to explore additional functions. The max and the min function return the largest and smallest values, respectively, from all the elements in tuple, provided that the elements can be converted to comparable types. The sum function adds up the elements of tuple if they are of the type that support addition, such as integers, floats, or even booleans. The sorted function returns the list of sorted elements from a tuple. You can reverse the sorting order by using the reverse argument. And the reversed function reverses the order of elements in a tuple. Here, the result of reversed is converted to a tuple because reversed returns an iterator, not a tuple. Converting it back to a tuple ensures the output remains the tuple's immutability and sequence properties. The any and all functions operate on sequences whose elements are of type Boolean or can be converted to Boolean values. They return true or false depending on the following questions. Is at least one of the elements true for the any function? And are all elements true for the all function? The provided example uses integer list, which can be converted to Boolean values, where 0 is treated as a false and any non-zero value as true. Now is also great time to discuss the zip function. It takes elements from each sequence provided as an argument, processes them in parallel, and combines them into tuples. If the sequences have different lengths, zip stops when the shortest sequence is exhausted. In the example, we convert the object returned by zip into a list, as it is otherwise an iterator, a sequence type that does not have nicely formatted string representation for display purpose. Finally, let's talk about tuple methods, although they are significantly fewer compared to lists. Due to their immutability, tuples support only two of the methods we encounter while discussing lists. These are count, which returns the number of times an object passed as an argument appears in the tuple; index, which returns the position of the first occurrence of the specified element in the tuple. The search range can be further narrowed by providing optional start and end arguments. In this video, we explored tuples, one of Python's fundamental data structures, known for their immutability. We discussed their properties, how to create them, operations, and few useful built-in functions that can simplify working with sequences. Over time, we will uncover more tools and possibilities that Python provides and see how its various components work together. For now, thank you for watching and see you in the next episode.